Good afternoon to all. Am I audible? Hello, am I audible?
Yes, sir.
Okay, the screen is visible to all, is it?
Yes, sir.
Okay. In the last lecture, we seen that what is the definition of subspace. Okay, let V over F be the vector space. A non-empty subset W of V is called a subspace of V if W itself a vector space over the F, the field F, with respect to operation vector addition and scalar multiplication in V. Okay, the same operation on V. Okay, now, and also we seen that some examples of vector space. Okay, the zero space and whole space V is the vector subspace of itself, V over F. And the second one, if W is equal to A0B, where A and B belongs to R, is the subspace of R3 over R. Okay, so here W over R is the subspace of R3 over R. Okay, and also we seen that the necessary and sufficient condition for a non-empty subset of W of a vector space V over F to be a subspace of V is A and B belongs to F and U and V belongs to W, then the product of AU plus product of BV, that is AU plus BV belongs to W. Okay, if this condition holds, then we can say that W is the subspace of V. And if W is the subspace of V, then it implies AU plus VV belongs to W. Okay, this is the statement implies and implied. Okay, if this one is true, in arithmetic we get this one. And if this one is true, then W is the subspace of V. Okay, so today we will see some more examples of one theorem and some examples of the subspace. Okay, and this theorem is intersection of any number of subspaces of the vector space V over F is the subspace of V over F. Now, the next theorem is the union of two subspace is a subspace if one is contained in other. Look at this one. The next theorem is the union of okay two subspaces, the union of two subspaces is a subspace. Okay, if one is contained in other, contained in other. Okay, look at the proof now. Answer. Proof. Let W1 and this one is W2 be a subspace, a subspaces of a vector space V over F. V over F. Okay, capital V over F, such that one is contained in other. That means W1 is contained in W2. Okay, this is the symbol of contained, that is subset of W1. W1 is the subset of W2, or we can take W2 is subset of W1. Okay, so here the W1 is contained in W2, or it may be possible of W2 is contained in W1. Okay, this is the possibilities. Now we have to prove that the union of two subspaces is subspace. Okay, now to prove that, we have to prove that W1, okay, union of two subspace, union W2 is a subspace. Okay, W1 union W2 is subspace of V over F. Okay, by last theorem, in the previous theorem, if we prove this A into U plus B into V belongs to W1 union W2. Okay, if U and V belongs to W1 union W2 and A and B are the belongs to element of F. Okay, if you take this one and if you show that AU into BV, this element belongs to W1 in union W2, then we get W1 union W2 is the subspace of V over F. Okay, now look at here. Now, if take W1 is contained in W2. Okay, and what we have, W2 is what? Is the subspace. Is the subspace of V over F. Okay, W1 is contained in W2 and W is what? Subspace of V over F. So this implies W1 union W2 is equal to what? Here W1 is contained in W2. Means W1 is bigger than W1. So and this implies W1 union W2 is what? W2. Okay, any doubt? Suppose this is W1. It's contained in W2. Okay, what is W1 union W2 is? W2. Okay, so here W1 in contained in W2. So this means W1 union W2 is what? Is equal to W2. And what we have W2 is what? Is a subspace of V over F. Okay. Now again, if suppose W2 is contained in W1, and what we have, W1 is a subspace of V over F. Okay, if suppose here we have W2 is contained in W1. So what we have, W1 W1 union W2 is equal to what? W1. And what we have, W1 is subspace of V over F. This means in both the cases, if W1 is contained in W2 or W2 is contained in W1, W1 union W2 is a subspace, is the subspace of V over F. When? If one is contained in other. Okay, any doubt up to here? Any doubt up to here? Okay, so here the
No,
union
sir.
of two subspace is a subspace if one is contained in other. Now we have to prove the converse part. Okay, what is the converse statement? Conversely, look at this. Conversely, suppose that W1 union W2 is a subspace, is the subspace of a vector space of the vector space. Okay, suppose that W1 union W2 is subspace of the vector space, and we have to prove that. Okay, TPT means to prove that either W1 is contained in W2 or W2 is contained in W1. या दोन्ही पैकी एक जरी ट्रू असायला हवा. कधी? when W1 union W2 is the subspace of vector space V over F. Okay, now suppose the contrary statement. Suppose the contradiction. Suppose the contradiction. What is the contradiction statement? Look at here. Suppose the contradiction W1 is not the subspace, not the subspace, sorry, not the W1. Suppose the contrary W1 is not the subset, it's not the subset of W1, W2, sorry, W2. Look at here. Here we have to prove that this statement. And here we are assuming the contradiction statement. What is the contradiction of this one? Here we have to prove that W1 is contained in W2. And we assumed that W1 is not the subset of W2. That means W1 is not contained in W2. Okay, and also, what is the contradiction of this one? W2 is also not the subset, not the subset of W1. Okay, that is in symbol, we can write W1 is not contained in W2. Okay, and W2 is not contained in W1. ओके, आपल्याला काय प्रूव्ह करायचं आहे? एक तरी हा W2 आहे आणि हा आहे W1. Either we have to prove this one or this one. This is the W1 and this one is the W2. Either we have to prove this one or this one. But here we assume the contradiction. What is the contradiction statement? W1 is not contained in W2. म्हणजे हा तुमचा W1 आहे, हा W2. हा W2 आहे, हा W1. हा पूर्णपणे ह्याच्यामध्ये कंटेंड नाहीये असं आपण काय केलं? अज्युम केलं. ओके, wait a minute. That is, in the symbolic form, we can write W1 is not contained in W2 and W2 is not contained in W1. Okay, now look at here. Now, W1 is not contained in W2. So this implies there exists an element U belongs to W1. Okay, U belongs to W1 such that U is not the element of W2. ओके, हा W1 हा W2 पेक्षा वेगळा आहे, हा ह्याच्यात पूर्णपणे कंटेंड नाहीये. म्हणजे असा एक तरी एलिमेंट एक्झिस्ट होईल. At least one element U belongs to W1 such that U does not belongs to W2. Now, W2 is not contained in W1. This implies there exists an element V, okay, belongs to W2, okay, such that V does not belongs to now W1. Okay, now from this we get, look at here, from this it follows that U belongs to W1 union W2. Okay, and that V belongs to W1 union W2. Okay, U हा W1 मध्ये आहे म्हणजे कशाला असणार? U हा belongs to W1 union W2. V belongs to W2. It means we have V belongs to W1 union W2. Okay, now U and this V belongs to W1 union W2. And what we have, look at here, W1 union W2 is what? Subspace of the vector space. V over F. Okay, now here U and V belongs to W1 union W2, and what we have, this union W1 union W2, okay, is a subspace. Okay, subspace. Okay, so this implies हा सबस्पेस आहे म्हणजे काय आहे, हा ऍडिटिव्ह ग्रुप आहे. ओके, अबेलियन ग्रुप आहे. So this means U plus V also belongs to W1 union W2. This implies U, okay, U plus V belongs to W1 union W2, and or sorry, wait a minute. U plus V belongs to W1 union W2. This implies either U plus V belongs to W1 मध्ये तरी असेल, or U plus V, okay, V plus V belongs to W2. त्याच्या युनियन मध्ये आहे म्हणजे काय असणार होतं, U plus V either it belongs to W1 or U plus V either it belongs to W2. Okay, now look at it. U belongs to W1 from this. U belongs to W1. And from this, U plus V belongs to again W1. So this implies the subtraction of these two elements, U plus V, okay, minus U belongs to what? W1, because W1 is the subspace. Because since W1 is subspace, okay, U plus V minus U, what we get? This one is V belongs to W1. Okay, but what we have, V does not belongs to what? Here, V does not belongs to W1, but here we get V belongs to W1. Okay, but we have that V does not belongs to W1 from this. Okay, and again, what we get? We get the contradiction. कशामुळे हा contradiction? Because our assumption is wrong. What is the assumption? Look at here. Suppose W1 is not the subset of W2. This assumption is wrong. Okay. Now again, what we have here? Look at it. U plus V belongs to W2. U plus V belongs to this W2. Okay, and V belongs to W2 from this one. V belongs to W2. Okay, this implies, but W2 is the subspace. So the subtraction of these two elements, U plus V minus V belongs to must be in W2. So this implies U plus V minus V. What we get? U belongs to W2. But U does not belongs to W2. Why? Look at it. U does not belongs to W2. Okay. Hence, we get a contradiction. Okay. Why? Because hence our assumption is wrong. Assumption is wrong. What is our assumption? W1 is not contained in W2, or W2 is not contained in W1 is wrong. Okay, hence we must have W1 is contained in W2 or W2 contained in W1. Okay, that is one is contained in other. Okay, hence if W1 union W2 is what? Subspace of V over F, then okay, one is contained if and only. Okay, not then. If and only if. Hence, W1 is union W2 is subspace of V over F if and only if one is contained in other. Okay, so this is the proof of the theorem. What we prove here, look at here. This one. The union of two subspace is subspace if one is contained in other. एखाद्या दोन सबस्पेसचा युनियन कधी सबस्पेस होईल जेव्हा वन इज कंटेन्ड इन अदर. ओके, एनी डाउट अप टू हियर?
नो सर.
ओके, समजते का डोक्यावरून जाते सर्व? स्टॅटचे विद्यार्थी आहेत ना तुम्ही?
समजतंय, तुम्ही म्हणाला डाउट्स.
Okay. Now the next point, we see some examples. Okay, wait a minute. Look at it. What is the question? Question is that, show that, first example, question number 1, show that W is equal to the set X, Y, and phi Z. Okay, such that X, Y, and Z are the real number. Is a vector subspace, that is subspace, vector subspace of R3 over R. Okay, what is R3 over R? Three coordinate, order a triplet, all the entries from the real number. Okay, we have to show that this W is the subspace of R3 over R. That is to prove that W over the field R is subspace of R3 over R. Okay, now look at it. Solution. Let A and B belongs to capital R, and U and V, these are the two elements from W. हा कोणते एलिमेंट आहे? W मधले कोणतेही दोन एलिमेंट आहेत. Then what is the nature of U and V? U is equal to x1, y1, and 5z1. Suppose this is the U, x1, y1, and 5z1. And what is V? V is equal to x2, y2, 5z2. Okay, where x1, y1, z1 and x2, y2, and z2 are the elements of real number. Okay, we have one theorem. if we have to show that this W is the subspace of R3 over R, then what we have one theorem. If we prove that AU plus BV belongs to that W, then this W automatic we get the subspace of R3 over R. त्यांचा जो काही हा एलिमेंट आहे, जर हा एलिमेंट माझ्या डब्ल्यू मध्ये असेल, म्हणजे या टाइप मध्ये जर असेल, तर तो काय होईल, माझा सबस्पेस होईल. कोण? डब्ल्यू. Okay, A and U and V are the elements of W, and A and B are the elements of what? F. Okay, F काय तुमचा real number. Okay, now look at here. This is all the given things. Now AU plus BV, okay, small v, is equal to A into what is U? X1, Y1, 5z1. Okay, plus B into what is V? X2, Y2, 5z2. Okay, which is equal to, this was AX1, A Y1, A 5z1. Okay, plus B X2. Okay, multiply this B to give all the coordinates. Okay, B Y2 and B 5z2, which is equal to A x1 plus B x2. This is the first coordinate. Second coordinate, A y1 plus B y2. Okay, and 5 A z1 plus B z2. Okay, this is one is the third coordinate. Okay, any doubt up to here? Any doubt up to here?
No, sir.
Okay, now this is the element AU plus BB, small u. Okay, now look at here, AU plus BB. This one is real number. This one is real number. This one is also real number. Now, here, A into U plus B into V. This element belongs to W. Okay, W चा nature कसा आहे पहा. X, Y, 5Z. ओके, आता हा जो काही येईल त्याला समजा आपण X म्हणला, कॅपिटल X. हा जो काही येईल त्याला आपण Y म्हटलं, आणि हा जो काही म्हणतो त्याला म्हटलं Z. Then what we have? The nature of AU plus PV is in the form for X, Y, 5Z. Okay, so that means AU into BV is the element of what? W. Okay, for A and B belongs to real number and U and V belongs to W. Okay, U and V कशात नव्हते तुमचे? W मध्ये. Okay, so here we prove that for any AB belongs to R and UV belongs to W, this implies A into U plus B into V belongs to W. This implies W is subspace of R3 over R. Okay, any doubt? Okay, so this is the proof of the,
No, sir.
okay, this is the solution. Now, the second one. Second one. Show that W is equal to A, B, C, such that A, B, and C are rationals. Okay, rational number. What is rational number? The number which is in the form of P by Q, where Q is not equal to 0 and P, Q are integers. Okay. W is equal to A, B, C, where A, B, C are rationals number. is not a subspace, not a subspace of R3 over R. ओके. एखादा एक्झाम्पल जर सबस्पेस दाखवायचा असेल तर काय दाखवावं लागेल? प्रत्येक एलिमेंटसाठी सगळे कंडिशन्स काय व्हायला पाहिजे? ट्रू व्हायला पाहिजे. ओके. हियर व्हॉट वी हॅव टू शो दॅट this W is the not the subspace of R3 over R. Okay. So if we get one example such that one of the property does not satisfy by this W, then we can say that this W is the not the subspace of R3 over R. Okay, just we have to show that one counter example such that A into U plus B into V does not belongs to W. Okay, A and a B, these are the elements of R. Okay, this is the field. And if you take U and V belongs to W, okay, and show that one counter example such that A into U plus B into V, this element does not belong to W, then we have W is the not the subspace of R3 over R. Okay, so not negation दाखवायचं असेल तर काय one counter example जर तुम्ही दाखवला तर sufficient. Okay, if you have to just show that this W is the subspace of R3, so prove this W satisfies the all the properties for all the elements. Okay, now look at here. What we have to show here, this W is equal to A, B, C ordered the triplets so that A, B, C are the rational numbers. Is the not the subspace of R3 over R. Okay. Solution. Look at the solution. Given. What is given to us? This is the W, which is equal to A, B, C, such that this A, B, C are rational. Okay, that is what A, B, C belongs to set of natural number, that is Q. Okay, the set of rational number denoted by Q, where Q is what? Set of rational numbers. Okay, now if we take U is equal to A, B, C, then what we have? A, B, C are what? Are the elements of Q. And if X belongs to R, then X into U. Okay, the scalar multiplication law. Okay, in the vector space, X into U. हा X कुठून आले तुमच्या फील्ड R मध्ये, and U is the vector. Then X into U कुठं असायला पाहिजे माझा? W मध्ये. Okay, so here X into U, what we get? AX, BX, and CX, which is not belongs to W. Hence, W is not a subspace, not subspace of R3 over R. आता म्हणतात तुम्ही X into U is equal to AX, BX, CX. Why this element not belongs to W? Okay. X is what here? PL number. For example, okay, suppose this is one is U, 1 by 3, 2 by 3, 5 by 3. Okay, this is the element U. Belongs to what? W. These are rational number. Okay, now take X is equal to root 2. which belongs to set of real number. Okay, this is the irrational number, but this one is also real number because irrational number is the subset of real number. So hence x is equal to root 2. This belongs to R. Now x into u is equal to what? Root 2 into 1 by 3, 2 by 3, and 5 by 3, suppose. Okay, what is the product of this two one? Root 2 divided by 3, 2 root 2 divided by 3, and 5 root 2 divided by 3. Okay, now tell me whether this number belongs to W. Hmm. Is it true? W मधले एलिमेंट कसे आहेत सगळे? A, B, C, such that this A, B, C all are rational number ना. हे rational आहेत का? आहेत का rationals?
Yes, sir.
Rational आहेत. हे rational दिसते ना, root 2. Root 2 is the irrational number. Okay, so x into u is the not belongs to what? W. Okay. So this element not belongs to W because all the entries from this x into u not belongs to rational. These are the irrational number. So hence the scalar multiplication law does not hold in W. This implies W हा काय पाहिजे? Itself vector space पाहिजे ना. जर subspace असायला हवा तर तो itself the vector space. But here the scalar multiplication law does not satisfy in W. Okay, so hence W is not a vector space. Hence W is not a subspace. Okay, any doubt now?
No, sir.
Okay, now the next example. Third one. Question number 3. Each W1 is equal to x, 2x and x plus 1. Okay, W मधला प्रत्येक एलिमेंट कसा आहे? x, 2x आणि x plus 1 या फॉर्म मध्ये. Such that this x belongs to real number. A subspace of V3, that is V3 म्हणजे काय तुमचा? R3 over R. Okay. Is W1 is the subspace of R3 over R. हा 3 म्हणजे काय डिनोट करतोय? 1, 2, 3. 3 ट्रिपलेट आहेत म्हणून तो 3 डिफाइन करतो बरं का. 3 डिनोट करतोय R3 over R. Okay, each W1 is the subspace of R3 over R. Question mark. Why? Explain. तर असेल तर explain, नसेल तरीही explain कर. Okay, now look at it. Answer. What is given to us? Suppose this is the W1. Okay, x, 2x, x plus 1, such that this x belongs to set of real number. Okay, now take any two elements from this set. Suppose u is the element from this set, and the nature of u कसा असेल माझा? x, 2x, x plus 1. Okay, and let v be the also element from the W1. That's a nature कसा असेल? असंच असेल. Suppose this one is y, 2y, y plus 1. Okay, such that x and y belongs to R. Okay, by the definition of W1, this x and y belongs to R. Hence, U and V belongs to the set W1. Okay. Hence, V and V belongs to what? W. Okay. Now take any two real number. Now, A and B are the two elements from this scalar. What is the scalar here? Sorry, what is the field here? R. Now, take any two element from the R, and U and V belongs to W1. This implies AU plus BV. What is this element? A into x, 2x, x plus 1, plus B into what is y? What is V? Y, 2y, y plus 1. Okay, which is equal to ax, 2ax, a into x plus 1. Okay, plus by, 2by, b into this is y plus 1. The addition of these two vectors now. Ax plus by. Okay, now take 2 common. 2ax plus by. Okay, now third vector. What is the third vector? What is the third vector? Wait a minute. This one is in the first bracket. Ax plus this one ax, write down in the first bracket, and this is one is by. Okay, into a plus. Okay, तुमचा कसा आला एलिमेंटचा नेचर पहा इथे पहा a into x plus 1 plus b into y plus 1, which is equal to ax plus a plus by plus b. Now take these two elements in one bracket. So this is ax plus by, and this one plus a plus b. Okay, so write down third element, ax plus by plus a plus b. Okay, so this is the third coordinate. Okay, any doubt?
No, sir.
Okay, so this implies AU plus BV is equal to AX plus BY. This first coordinate 2 into AX plus BY. Third coordinate AX plus BY plus A plus B. Okay, now tell me whether this element AU plus B either belongs to W1 or not belongs to W1. What is the nature of W1? इथे x हवा, the 2x हवा, आणि इथे काय असावं x plus 1 असायला हवा. ओके, नाउ लुक एट हियर. हा ह्याला समजा मी x म्हणला, कॅपिटल x. हा काय आलाय 2
Belongs
into
to.
capital X. 2 into हा पहा 2 into capital X. हा काय आला x plus a plus b. ओके, तर असायला काय हवा इथे 1. Okay, but here we have a plus b. Okay, but a plus b not equal to 1 always. Why? Because a and b are the any element. कोणत्याही दोन रियल नंबरचे ऍडिशन 1 थोडीच येते. 2 plus 3 हे दोन रियल नंबर आहेत. समजा मी a जर 2 घेतला, b जर 3 घेतला, तर किती येईल? a plus b 5 ना. हा 1 थोडीच येईल. प्रत्येक a आणि b साठी थोडीच 1 येईल. Okay, so the nature of AU plus PV. Okay, समजा याला मी x म्हटला, कॅपिटल x. हा काय येतोय 2x. ओके, मग हा काय आहे x प्लस हा किती यायला पाहिजे माझा 1. पण हा a plus b1 येतोय का for any a and b? No, not possible. So hence this implies AU plus BV does not belongs to W1. Okay, hence here u and v belongs to w1 and a and b are the elements of set of real number. This implies AU plus PV does not belongs to W1. Hence, W1 is not subspace of not the subspace of R3 over R. Okay, or this R3 we can denote by this one also V3 over R. Okay, any doubt? Up to here. Any doubt? If anyone who have doubt, they can ask. Okay. So for today, it is sufficient now. Now the next lecture, on next lecture, Monday, we will see what is the linear combination. Okay, the linear combination, the linear span. Okay, what is linear dependence and independence. Okay, for today, it is sufficient now. Okay, up to here, any doubt?
No, sir.
Okay, the doubt asking.